So, hi dear students, this is a run of second live session. Okay. In the first part of the run of, we have completed almost definition portion. Okay. Now in this session, we are going to learn some get problem based concept. Okay. SCS-CN method for calculation of abstraction. SCS-CN method. Soil Conservation Service curve number method. Developed by Soil Conservation Services of USA. Used for the estimation of direct runoff depth from rainfall depth. Here P is total precipitation and PE, effective precipitation or direct surface runoff. And actually we are going to establish a relationship between P and P by SCS-CN method. So guys, this SCS-CN method is based on water balance equation. P is the total amount of precipitation, IA, initial abstraction, water involved in or water lost in interception, depression storage, evapotranspiration. So remaining water enters soil as infiltration and further remaining water is visible in the form of runoff, surface runoff. So from water balance equation, total precipitation P is equal to initial abstraction, interception, depression storage, evapotranspiration plus infiltration plus direct runoff. Okay, that is surface runoff. So friends, here P is total precipitation, IA, initial abstraction F, cumulative or total, infiltration PE, excess precipitation or effective precipitation, excess runoff, effective runoff, direct surface runoff in interval of time delta T. This is a very simple relationship. It is obtained by balancing mass of water. Now we modify this water balance equation. PE is equal to P minus IA minus F. So here excess runoff or excess precipitation or excess rainfall is equal to total precipitation minus initial abstraction minus total infiltration. Okay. So PE is less than or equal to P minus IA. If the value of F is 0, then equality of this relation will hold. And if infiltration is of some value, so here PE becomes less than this value. Okay. So guys, this is modified expression under this consideration. Okay. Now friends, we can write PE is equal to K times P minus IA. Okay. If the value of infiltration is 0, the value of infiltration becomes 0 for hard surface, cemented surface. Okay. Because water जो है ना इन्फिल्ट्रेट नहीं कर पाएगा, रॉक सरफेस हो या पेवमेंट हो, हार्ड सरफेस हो, तो उस केस में के की वैल्यू क्या हो जाएगी? 1 हो जाएगी. ओके. अदरवाइज के हैज वैल्यू लेस देन यूनिटी और अदर सॉइल्स. ओके. तो के की वैल्यू से हम इस रिलेशन को अचीव कर सकते हैं. पीई इज इक्वल टू के टाइम्स पी माइनस आई ए. नाउ डियर स्टूडेंट्स, we define if total infiltration, it is less than equal to potential maximum retention or infiltration. Potential maximum infiltration. Maximum possible infiltration is S. Okay. So in real cases, the value of infiltration may be less or equal to this potential maximum infiltration. Okay. Now we can write F is equal to K times S. K involved in this relationship and K involved in this relationship. Both are same reason. We use the same proportionality constant in both relations because soil type, its hydrological condition, cover, use and antecedent moisture conditions are affecting both excess runoff and infiltration. Okay. Excess runoff, this is excess runoff. So excess runoff and infiltration both are affected by same factors like hydrological condition, soil type, cover, use, antecedent moisture condition. These are factors affecting excess runoff from catchment. तो catchment की soil का type क्या है? Like sandy soil, sandy loam soil, deep sandy loam soil, shadow sandy loam soil, clay soil. So these are types of soil. Cover, use, antecedent moisture condition. Okay. तो इन सब पर डिपेंड करता है P and F. P और F को जो अफेक्ट करने वाले फैक्टर्स है वो सेम है. We use the same proportionality constant in these two relationship because infiltration and excess runoff both are affected by same factors like soil type, cover, use, moisture condition and other hydrological conditions. Done. Now divide 2 by 3. 2 is excess runoff or excess precipitation is equal to K times P minus initial abstraction. And 3 is F is equal to Ks, where S is potential maximum retention or infiltration of a particular soil. This is 2 and this is 3. 1 तो आपको पता ही है, total amount of precipitation is equal to infiltration plus initial abstraction plus excess runoff. This is 1. So divide 2 by 3. PE upon F is equal to P minus IA upon S. Okay. अब आपको करना क्या है? Putting the value of F from equation 1 in equation 4. This is equation 4. The value of F from equation 1 is P minus IA minus P. Okay. Done. तो क्या हो जाएगा? P upon P minus IA minus PE is equal to P minus IA upon S. Okay. Take inverse on both sides. So P minus IA minus PE upon PE is equal to S upon P minus IA. Okay. Friends, here this will give P minus IA upon PE minus 1 is equal to S upon P minus IA. यहां से क्या मिलेगा आपको? P minus IA whole square, P minus IA whole square upon PE is equal to S plus P minus IA. S plus P minus IA. लास्ट में इधर लिखा हूं मैं P minus IA. Done. So PE becomes P minus IA upon PE from this relation. PE is equal to P minus IA whole square upon P minus IA plus S. So this is result. Dear students, here we have result. Remember this result. This year we have a question in our GATE examination from this relation. Okay. So excess runoff due to precipitation P over a catchment where IA is initial obstruction inside catchment and S is potential maximum retention. That is potential maximum infiltration. So this relation is obtained by this concept by SCS-CN method. Okay. Done. अच्छा लगा होगा आपको? बस ये एक्सप्रेशन आपको याद करना है, इसमें सबका मीनिंग आपका क्लियर है. Now, by a study of results from many small experimental catchment or watershed, an empirical relation was developed between IA and S. IA is some percent of potential maximum retention. Okay. IA initial abstraction is percentage of potential maximum retention. So if IA is 20% of potential maximum retention and this is mentioned in your problem, then we can write IA is equal to 0.20 S, and potential maximum retention is always given in problem. If there is no information about percentage of IA, in that case we will consider IA is 20% of potential maximum retention. Most of the time, students directly remember this relationship and without checking percentage mentioned in problem, they take IA as 20% of the S. They don't have concept about the relationship between IA and S like this. They remember this formula directly. Such students remember this formula directly in order to calculate excess runoff from precipitation P where S is given in the problem, which is potential maximum retention. So most of the students remember this formula directly and they don't have any concept how this formula comes. Even IA is mentioned 30% of the S, but such students use this formula. ओके और आंसर भी मेंशन आता है इसका ऑप्शन में, वो रॉन्ग हो जाएंगे. इसी तरह जो है ना 2 साल पहले बहुत सारे स्टूडेंट ने गड़बड़ी पैदा किया था. मेरे स्टूडेंट ने पैदा किया था. क्यों किया था 2 साल पहले? क्योंकि जो है ना हमारे जो टीचर पढ़ाए थे ना डायरेक्ट इसको पढ़ा दिए थे, यही डायरेक्ट रिजल्ट लिखा दिए थे. अब उसी साल जो है ना प्रॉब्लम आया और रॉन्ग करके आए. वो पहली बार आईए का जो है ना परसेंटेज मेंशन था कि आईए कितना परसेंटेज है पोटेंशियल मैक्सिमम रिटेंशन का, 30%. बट स्टूडेंट तो डायरेक्ट फॉर्मूला ये यूज किया था. ये 30% देने के बावजूद भी वो डायरेक्ट इस फॉर्मूला को यूज किया था. आप लोग नहीं करेंगे. फर्स्ट चेक percentage of S for IA. If this is not given in the problem, in that case we consider IA is 20% of potential maximum retention. So लॉजिक यहां पर आपने देख लिया ना क्या है लॉजिक 20% 30% यूज करने का. सो फ्रेंड्स, इन द absence of percentage of S for IA, we use IA is 20% of potential maximum retention. Then excess runoff becomes P minus IA, and here IA is 0.20 S whole square upon P minus IA. P minus IA, where it is 0.20 S plus S. So this will give P minus 0.20 S whole square upon P plus 0.8 S. So don't use this relation directly. You must remember the situation in which you will apply this. Plotting the data for P and P from many watersheds. For various watersheds, we are going to plot PE, excess runoff against precipitation. So on this axis we have total amount of excess runoff, and on this axis it is total precipitation and rainfall in inch. Okay, friends, now we consider 4-inch total precipitation. Okay, 1 inch 2.54 centimeter. For this curve, this is the amount of excess runoff. For this curve, excess runoff decreases. For this curve, corresponding to 4 into 2.54 centimeter total precipitation. This is the amount of excess runoff, and so on. So excess runoff for this curve corresponding to a particular watershed or catchment. this curve is plotted for a watershed. So same amount of precipitation is producing larger excess runoff for this curve corresponding to a particular catchment. It means definitely this is drawn or plotted for a watershed which is having less infiltration. Infiltration is less for watershed for which this curve is plotted. ये कर्व जिस वाटरशेड और कैचमेंट और सॉइल के लिए लिया है उसकी इनफिल्ट्रेशन बहुत कम है, सो दैट maximum almost all precipitation is converting into excess runoff. Runoff में जा रहा है. Now we talk about this curve related to some another watershed or catchment. For the same amount of precipitation, this catchment for which this curve is plotted gives comparatively less excess runoff. So guys, corresponding to this curve, watershed is having comparatively larger infiltration rate. So it is producing less excess runoff. So higher curve number is assigned to watershed or catchment which is having less or almost nil infiltration. Then we are going to make a standard relationship for all kind of watersheds because shape variation of all curves are identical. So we are going to make a standard about these curves which are plotted for different watersheds. अब मैं स्टैंडर्ड एक रिलेशन लिखने जा रहा हूं. A dimensionless curve number CN is defined, okay, such that its values vary between 0 and 100. So curve number 100 means curve number 100 for watershed means that watershed else maximum amount of excess runoff from precipitation. Infiltration is less or nil for that watershed. Higher curve number means we'll get higher excess runoff. Lower curve number means infiltration is higher, so we'll get lower excess runoff. Okay. So curve number 100 for impervious surface to water, infiltration will be 0 and all precipitated water will be available in the form of excess runoff. पूरी की पूरी runoff में convert हो जाएगी after filling water requirement in initial loss like interception, डिप्रेशन स्टोरेज. उस सबको अगर नेग्लेक्ट कर दिया जाए, स्टॉर्म के लिए बात किया जाए, क्लाउड कॉज करने वाले स्टॉर्म को, तो उसका अमाउंट बहुत कम होता है. इन दैट केस वी आर गेटिंग एक्सेस रन अप इक्वल टू प्रिसिपिटेशन. डन मेरे भाइयों. फॉर नेचुरल कैचमेंट ऑफ वाटरशेड कर्व नंबर is less than 100 because such natural soil or surfaces will show some अमाउंट ऑफ इनफिल्ट्रेशन. ओके, कुछ ना कुछ इनफिल्ट्रेशन शो करेगा. बट मैं अगर इम्परवियस सरफेस लाइक cemented surface, infiltration is zero. So in that case we'll get maximum excess runoff from precipitation. So dear students, this is dimensionless number. Curve number is dimensionless number, and it is 1000 upon s plus 10. Okay, where s is in inches. Cn curve number is equal to 1000 upon s plus 10, where s is in inches. This is also in inches, and numerator is also in inches, so that we will get a dimensionless number. Now convert numerator and denominator in centimeter. So 1 inch is 2.54 centimeter. So we multiply numerator by 2.54 and denominator by 2.54. But if we consider s is in centimeter, then no need to multiply 2.54 to this s. Only convert this 10 inches in centimeter. Okay, डन फ्रेंड्स, क्लियर है आपका ये? तो यहां से s की वैल्यू हमारा कैलकुलेट होके आ जाएगा. s 2540 अपॉन कर्व नंबर माइनस 25.4. So Cn 2540 upon s plus 25.4, where s is in centimeter. अगर आप s को इंच में रखेंगे तो Cn का ये फॉर्मूला यूज करेंगे. अगर s को सेंटीमीटर में पाना चाहते हैं या यूज करते हैं यहाँ पर, तो आपको यहाँ पर 2540 यूज करना पड़ेगा एंड यहाँ 25.4 यूज करना पड़ेगा. ओके, नाउ फ्रेंड्स, फॉर impervious surface s would be 0, that is infiltration. Potential maximum infiltration or retention will be 0. When s becomes 0, s अगर 0 हो गया तो कर्व नंबर 100 आएगा. So 100 curve number is related to impervious surface, the surface which is not allowing water to pass through it. Infiltration through that surface is 0. Curve number, higher curve number means lower infiltration. So maximum portion of precipitation is converting into excess runoff that will join a stream at the outlet of the catchment. Curve number depends upon soil type. So guys, here we have hydrological classification of soil. Okay, in order to define curve number. So group A, such soil has low runoff potential. Low runoff potential means curve number is low. It means infiltration is higher. Dear students, we have deep sand soil which is having a higher infiltration. So most of the precipitated water is converting into infiltrated water. Okay, so we are getting less surface runoff or excess runoff. So this is a group A soil. Deep sand is group A soil. It has low curve number due to high infiltration. Group B. Now, friends, we reduce infiltration. So, such soil has moderately low runoff potential. थोड़ा सा रन ऑफ पोटेंशियल बढ़ा, इट मीन्स इनफिल्ट्रेशन घटी हुई होगी, थोड़ा क्ले मिलना चालू हो गया. डियर स्टूडेंट्स, दिस इज डीप सैंडी लूम सॉइल. ओके, फाइन पार्टिकल्स अवेलेबल रहेंगे, इनफिल्ट्रेशन रिड्यूस होगा. ग्रुप सी, such soil has moderately high runoff potential. Okay, clay percentage in the soil is increasing, so infiltration rate is decreasing, and we are getting contribution in excess runoff by precipitation. Group D, such soil has high runoff potential. It means, guys, clay soil. Okay, so infiltration through clay soil is very small. So maximum fraction of precipitated water will be converting into excess runoff. Curve number will be higher. So curve number is increasing. Curve number is representation of excess runoff. Okay, जितना ही ज्यादा कर्व नंबर होगा उतना ही उस कैचमेंट से हमारा एक्सेस रनअप मिलेगा. लैंड यूज, किस टाइप का जो है ना लैंड यूज है? कल्टिवेटेड है, ऑर्चर्ड है, फॉरेस्ट है, पास्चर है, वेस्टलैंड है, रोड है, हार्ड सरफेस है. बिकॉज कर्व नंबर इज रिलेटेड विथ टाइप ऑफ लैंड यूज. लैंड का यूज कैसे हो रहा है उसी के अकॉर्डिंग कर्व नंबर होगा. कल्टिवेटेड है, कर्व नंबर लेस होंगे, इन्फिल्ट्रेशन ज्यादा होगा. ऑर्चर्ड, फॉरेस्ट, पास्चर कंपैरेटिवली इसमें इन्फिल्ट्रेशन कम होंगे, कर्व नंबर हायर होगा. ओके, रोड एंड हार्ड सरफेसेस जो भी प्रिसिपिटेट होंगे सब रनअप ही दिखेगा, इन्फिल्ट्रेशन बहुत कम, कर्व नंबर हायर होंगे. सो कर्व नंबर डिपेंड्स अपॉन लैंड यूज आल्सो. लैंड कवर, कैसा कवरिंग किया गया है, लाइक वेजिटल कवर, स्ट्रेट रो क्रॉपिंग हुई है या कंटूर्ड क्रॉपिंग हुई है, कंटूर्ड और टेरेसिंग हुई है या बंडिंग हुई है. ओके, so depending upon land cover will have curve number. Antecedent moisture condition. Okay, before precipitation, moisture of the soil will decide infiltration and therefore excess runoff. So antecedent moisture condition refers to the moisture content present in the soil at the beginning of the rainfall. किसी स्टॉर्म के बिगिनिंग में सॉइल मॉइस्चर कंडीशन क्या है उस पर भी आपका कर्व नंबर डिपेंड करता है. इफ सॉइल इज सैचुरेटेड एट द बिगिनिंग ऑफ अ पर्टिकुलर स्टॉर्म, infiltration will be lower and most of the precipitated water will be converting into excess runoff, surface runoff. So curve number will be higher for such soil which is having higher antecedent moisture condition. Okay, पहले से यानी कि किसी पर्टिकुलर रेनफॉल के पहले से ही सॉइल की मॉइस्चर कंडीशन क्या है. तो डियर स्टूडेंट्स, 3 levels of antecedent moisture condition are recognized by SCS, Soil Conservation Services, US based organization. MC1, soil is dry but not to wilting point. Okay, wilting point तक हमारा जो है ना रीच नहीं किया है. ड्राई है सॉइल बट जो ना वहां पर जो वेजिटेशन है अभी वो सूखने की कंडीशन में नहीं है. लेकिन मॉइस्चर अगर बेलो विल्टिंग पॉइंट चला जाए तो क्रॉप प्लांट्स स्टार्ट इट्स विल्टिंग. ये उसके बाद रिकवर नहीं होंगे, ये विल्ट आउट हो जाएंगे. Okay, so before reaching to wilting point, soil is almost dry, but a standing crop is still alive. If we irrigate, then plant will recover its health. Okay, so dear students, MC1 represent dry soil before wilting condition. MC2 average condition है. MC3 sufficient rainfall 5 दिन पहले हुआ है. Sufficient rainfall has occurred within immediate past 5 days. Okay, MC3 is defined like this. Sufficient rainfall has occurred within past 5 days. Soil is in saturated condition almost, and this will produce huge excess runoff. And friends, curve number for such antecedent moisture condition of the soil will be higher. Okay, so dear friends, here we have curve number of soil under MC condition 2. 2 of soil under MC. ये CN2 का मतलब है एंटीसीडेंट मॉइस्चर कंडीशन 2 है, मतलब एवरेज जो है ना मॉइस्चर है. लैंड यूज, कल्टिवेटेड लैंड, फॉरेस्ट, पास्चर, ऑर्चर्ड, रोड, पेवमेंट, वेस्टलैंड. सो ये लैंड यूज है. लैंड कवर, जो प्रैक्टिस हम यूज कर रहे हैं, स्ट्रेट रो क्रॉपिंग, कंटूर्ड एंड टेरेस्ड, इस तरह से हमने दिया. एंड हाइड्रोलॉजिक सॉइल ग्रुप, ग्रुप ए, ग्रुप बी, ग्रुप सी, ग्रुप डी. ओके, डियर स्टूडेंट्स, फॉर कल्टिवेटेड स्ट्रेट रो क्रॉप्ड group A soil, curve number is 76. Group B, तो जैसे जैसे हम A से D की तरफ मूव करते हैं, इनफिल्ट्रेशन रिड्यूस होते चला जाता है, क्ले परसेंटेज बढ़ती चली जाती है, कर्व नंबर इंक्रीज होते चला जाता है. A, B, C, D, कर्व नंबर इज इंक्रीजिंग. सो 1 example is sufficient to understand all factors affecting excess runoff, which is consequence of curve number. SCS-CN equation for Indian condition. For black soil under AMC 2 and 3, we take IA as 10% of potential maximum retention or infiltration. For black soil under MC2 and 3, average moisture and saturated black soil. This is formula to calculate excess runoff from precipitation P, where S is potential maximum retention. For black soil under MC condition 1, and for all soil having MC 1, 2, 3. Baki black soil MC 1 and remaining other soils of any moisture condition. We take IA as 30% of potential maximum retention. बाकी आपका फॉर्मूला मॉडिफाई हो जाए, बिकॉज we know P is P is P minus IA whole square upon P minus IA plus S. If we put the value of IA 0.10 S for black soil under MC condition 2 and 3 in Indian geographical boundary, so we'll get P minus 0.1 S whole square upon P plus 0.9 S. Okay. For black soil MC1 and all other soil, IA is 30% of potential maximum retention. So P becomes P minus 0.3 S whole square upon P plus 0.7 S. डन. सारे क्वेश्चन इसी पर आएंगे. कभी आइए दिया रहेगा तो वो परसेंटेज यूज कर लेंगे, नहीं दिया रहेगा रिमेंबर वी टेक 20% ऑफ potential maximum retention. Potential maximum retention is always given in the problem. If excess runoff is required from a precipitation P over a catchment where S is potential maximum infiltration or retention. Weighted curve number, guys, now we have its derivative. इसके डेरिवेटिव है और कुछ नहीं, खत्म हो चुका है ऑलमोस्ट सारे कॉन्सेप्ट. तो मैंने पूरा ट्राई किया हूं कि आपको कॉन्सेप्ट से लर्निंग हो. यहां पर कुछ भी मैंने रटवाया नहीं है, सब कुछ खोल के रखा है. weighted curve number is used to find curve number of catchment when it consists of different soil type, use, cover and AMC. Dear students, here we have a catchment. Suppose this area A1 has different soil type, land use, cover, AMC condition. So it has different curve number. Curve number is representative of excess runoff or infiltration. Okay. So due to different characteristic of this sub catchment, it has different curve number. Suppose its curve number is CN1. Similarly, inside this catchment area A2 has curve number CN2 due to its different factors affecting curve number like soil type, cover, use, moisture condition. Similarly, we have A3, CN3, A4, CN4, dot, dot, dot. So if we add this all areas, we will get total area of the catchment. So we have a very simple formula to find weighted curve number of this entire catchment under this varying condition. This is a single average value assigned to this entire catchment. CN1 A1 plus CN2 A2 plus dot 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 divided by CN चाहिए ना, तो एरिया से आपको डिवाइड कर टोटल एरिया ऑफ द कैचमेंट. ओके, सो दिस इज फॉर्मूला टू कैलकुलेट weighted curve number or curve number of catchment which is having different soils. Okay, rational method. Consider a rainfall of uniform intensity and very long duration over a basin. The runoff rate gradually increases from 0 to a constant value as indicated by the figure. So guys, we are considering a rainfall of uniform intensity and it is taking place for very long duration over a catchment, and at the outlet of catchment we are measuring the runoff, direct runoff. Okay, हम लोग बैठे हैं मेजर करने के लिए. So at the outlet of the catchment, amount of runoff increases from 0 to some maximum value and this will remain this will remain constant till precipitation. Suppose constant value of runoff is achieved at this time. Suppose this is peak and this peak takes place after concentration time, where entire catchment start contributing to the stream at the outlet of the catchment. Okay, जब वाटर कैचमेंट के रिमोटेस्ट पॉइंट से भी अगर आने लगे तब तक रेनफॉल हो ही रहा है, उस केस में जो है ना, अब उस कैचमेंट के आउटलेट में जो स्ट्रीम फ्लो हो रही है उसमें जो है ना पीक मिलेगा, आपको पीक रन ऑफ देखने को मिलेगा. सो पीक रन ऑफ is achieved by consuming time equal to time of concentration. Till now, rainfall is occurring. Now, rainfall ends here. Dear students, runoff starts decreasing and again it becomes zero. Actually, we are talking about surface runoff or excess runoff. We are not considering contribution of groundwater as base flow. Zero हो जाएगा. Done. QP, peak runoff. We are going to find peak runoff. Runoff into catchment area. Okay. CIF is runoff and A is catchment area. C is runoff coefficient. It is runoff upon. It is C is runoff upon rainfall. Okay. So runoff is C into rainfall. Dear students, rainfall आप जो है ना intensity of the rainfall use कर लीजिए in meter per second. I in meter per second. So C into I is the runoff rate in meter per second, centimeter per second, mm per second. Okay. So CI into catchment area. This is depth of runoff. Depth of precipitation से कितना depth हमें runoff का मिला into catchment area. CIA in meter square. So we will get runoff in meter cube per second by this relationship. Okay. QP in meter cube per second, CIA. Okay. Done. Equivalent runoff coefficient. We have a similar concept. Dear friends, this is catchment and we have sub catchment inside this catchment. Okay. So A1 and it has runoff coefficient C1. A2 runoff coefficient C2. A3 runoff coefficient C3. So runoff coefficient for entire catchment. Again we will use weighted average method to find runoff coefficient for entire catchment. A1 C1 plus A2 C2 plus dot 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 divided by A1 plus A2 plus A3. That is total catchment area. Okay. This is very simple problem. Dear students, a watershed has 60 hectare of row crop cultivated good terraced land with hydrologic soil group C. सब कुछ अब क्लियर हो रहा है ना? कवर, यूज, सॉइल कंडीशन, एमसी भी मिल जाएगा. द कर्व नंबर फॉर वाटर सेट फॉर MC2 is 80. Determine the volume of runoff for rainfall of 150 mm. Area 60 hectare. Curve number for water shed under MC condition 2 under given land use and cover. Rainfall 150 mm. इससे हमें एक्सेस रनऑफ कितना मिलेगा वो फाइंड आउट करना है. Dear friends, this is a very simple problem. First write expression for excess runoff. PE is P minus, here there is no information about percentage of S for IA. So we'll take 20% of S for IA whole square upon P plus 0.8 S. Precipitation is given 150 mm. Depth of precipitation is given. Depth of precipitation is given. First we calculate depth of excess runoff and then multiply depth of excess runoff by watershed area. This will give total volume of excess runoff. Okay, watershed area is given. For this calculation, S is required. And dear students, we know S is hidden in curve number. Curve number is 1000 upon S plus 10, where S is in inches. Okay. अगर फ्रेंड्स S की वैल्यू सेंटीमीटर में रखा जाए, मतलब डिजायरेबल हो, तो उस केस में क्या हो जाएगा, यही से रिलेशन जो है ना हमारा ये बन जाएंगे 2540 अपॉन S, where S is in सेंटीमीटर. 10 क्या बन जाएगा 25.4. समझते चलिएगा 25.4. एंड कर्व नंबर इज डायमेंशनलेस नंबर. कुछ भी में रखे ऊपर और नीचे डायमेंशन सेम होना चाहिए. इट इज गिवन 80. So from this relation we will calculate S in centimeter. It is 6.35 centimeter. Okay. Put the value of precipitation in centimeter also, and S already we have calculated in centimeter. We'll get P, depth of excess runoff, in centimeter. Convert this in meter, multiply by 60 into 10 raised to the power 4. This is watershed area to get the volume of excess runoff.